This is our first video on section 13.4 series. And before we start talking about series, we're going to introduce something called summation notation. Summation notation is a mathematical shorthand used to represent sums of numbers. The numbers being added need to follow some sort of pattern or rule that can be expressed by a formula. The Greek capital letter sigma is used. Sigma is a Greek letter S, and it was chosen because it's the first letter of the word sum, in English at least, I think also Latin. So by hand, usually sigma, capital sigmas are written either this way, sometimes people embellish them a little bit. These are exactly the same thing. There's not meant to be any difference. So let's practice using this sigma notation a little bit. So got to get used to the funny look of this thing. We have a sigma with something written below, something above, something next to it. And this is how we interpret the sigma notation. You're going to add up over and over again quantities that look like the expression, but you have to plug in specific numbers. You start out by plugging in the value at the bottom. So k equals 1 means plug a 1 in and write 1 squared. And then what you're supposed to do is you're supposed to use each integer from 1 until you get up to the integer at the top of the sigma sign. So this means from k equals 1 to k equals 4. So after k equals 1, you get to k equals 2, so you have to plug in 2 squared. Then k equals 3, 3 squared. Then k equals 4, 4 squared. And when you get up to that, plugging in the number on top, you stop. And so we're adding up these 4 squares. That's what that sigma notation represents. And this, of course, is 1 plus 4 plus 9 plus 16 is 30. So the value of this is just the number 30. That's a crazy way to say 30. And the way we read it is we say summation k equals 1 to 4 of k squared. So let's do another. Let's do summation k equals 1 to 8 of 3k minus 1. So we're going to take this expression and plug in k equals 1. So we get 3 times 1 minus 1. Plus plug in 2, 3 times 2 minus 1, plus 3 times 3 minus 1, plus 3 times 4 minus 1, plus 3 times 5 minus 1, plus 3 times 6 minus 1, plus 3 times 7 minus 1. I didn't leave myself enough space here. Plus 3 times 8 minus 1. I had to go all the way up to 8. So from k equals 1 to 8, plug in 1, plug in 2, plug in 3, plug in 4, plug in 5, 6, 7, and 8. And each one of these can be simplified. So 3 times 1 minus 1 is 3 minus 1 is 2. Then we have 6 minus 1 is 5. 9 minus 1 is 8. 12 minus 1, 11. Plus 14. Plus 17. Plus, looks like 20, plus 23. And then we got to add all this up. So notice k equals 1 to 8. There's 1, 2, 3, 4, 5, 6, 7, 8 terms that end up being added up when we simplify each one of those expressions. And the total here, I think it adds up to 100. Exactly. So here's a funny way to say 100. Now let's do one more, a little bit messier even. K equals 1 to 5 of 3 times negative 2/3 to the k. So we start out by recopying the expression, but plugging in this number at the bottom. And often you start at 1, sometimes 0, but there really you could start at any number at all for the lower limit. Here's k equals 1. And plus 3 times negative 2/3 squared plus 3 times negative 2/3 cubed plus 3 times negative 2/3 to the 4th plus 3 times negative 2/3 to the 5th. This is quite a mess of stuff here. I'm not even gonna write a little bit of this out by hand and then just give you an answer at a certain point. So this is what? This is actually, the first term's -2 because the 3's cancel. Then I think we get 3 times 4/9 is plus 4/3. You can check that. Then we're going to get a negative because we have a negative cubed, and I believe that's going to be -8/9. And then I get plus, when I simplify this, I'll have 16/27. And then finally the last term is going to become negative. Negative fraction to an odd power is negative. I think I get -32/81. And you're not going to have to do this by hand, but I think this comes out to be -110/81 when all those are added together. And that's our introduction to summation notation. And we'll start talking a little bit about what geometric series are in our next segment.